Hello, today we are talking about an additional rule for evaluating limits, and the rule is called L'Hopital's rule. Sorry. We use L'Hopital's rule to evaluate limits that would result in an indeterminate form if we simply plugged in. So here are indeterminate forms. These are things that cannot be evaluated. We don't know if these things are undefined. We don't know if they are zero. We don't know if they are infinity. We don't know if they are a number like 2 or 1/2. So all of these things mean I have no idea what the value is. And again, we can only use L'Hopital's rule if when we test our limit, we get one of these four indeterminate forms. Now there are other indeterminate forms, sorry, but we will not be addressing any others besides those four. So let's look at L'Hopital's rule. If f and g are differentiable functions, again, I can just take the derivative. If the limit as x approaches a of f of x divided by g of x, okay, pay attention to that, we need to have a fraction, produces one of the indeterminate forms, 0 over 0, infinity over infinity, negative infinity over infinity, positive infinity over negative infinity, then that limit will be equal to the limit as x approaches a of f prime of x over g prime of x. And again, provided those limits exist. So first thing we need to know, we have to have an indeterminate form. If we have an indeterminate form and we use L'Hopital's once and we get another indeterminate form, we can do L'Hopital's rule again, and we can do it as many times as we need. Note number 2, we cannot use L'Hopital's if we do not have an indeterminate form. So keeping those two things in mind, let's look at our examples. Use L'Hopital's rule to evaluate this limit. So the first thing that I need to do is I need to check. I need to check for an indeterminate form. So that's the first thing I'm doing. Now, you're going to do that every single time. You don't have to write the words down, but you need to show something like this, that we have plugged in the 3 and we get 3 squared minus 9 divided by 3 minus 3. And that gives me 9 minus 9 over 0, which is 0 over 0. And then I go, is that an indeterminate form? And I look back at my indeterminate forms, and there it is right there. So that is an indeterminate form, which means now I get to use L'Hopital. So I'm going to use L'Hopital's rule. So to do that, I'm going to take the derivative of the top and the derivative of the bottom, and that's the limit that I'm going to find. So the derivative of the top is just going to be 2x, and the derivative of the bottom is just going to be 1. So now I try and evaluate my limit, and if I plug in my 3, then I just get 2 times 3 divided by 1, which is just 6. So what that means is I now have the solution for the evaluation of the limit as x approaches 3 of x squared minus 9 over x minus 3, and that value we're going to get is 6. And that is L'Hopital's rule. So let's go ahead and look at example 2 now. So again, the first thing I'm going to do is I'm going to check for an indeterminate form. So I check for my indeterminate form by plugging in. I'm plugging in infinity. So I'm going to get 4 times infinity plus 1 divided by 1 plus 3 times infinity. We okay, infinity squared is infinity, so I can just call it infinity. And that is the top 4 times infinity plus 1. Well, that's infinity. The bottom 1 plus 3 times infinity. Well, that's infinity. And is that an indeterminate form? We go back to our list of indeterminate forms, and that is the second one we've been given right here. So we are good to go to use L'Hopital's. So now that I have that, I'm going to use L'Hopital. Please call it L'Hopital, please. Please call it that. Okay, sorry, that is a side note. So we're going to use L'Hopitals. We take the derivative of the top and we take the derivative of the bottom, and then we're going to evaluate the limit. The derivative of the top is 8x. The derivative of the bottom is 6x. So let's go ahead and try to evaluate that. That is 8 times infinity. Sorry. And on the bottom we have 6 times infinity, which is otherwise known as infinity over infinity, which means, guess what? We have another determinant form. Oh no. I think I said determinant. It's another indeterminate form, which means we do L'Hopitals again. So we use L'Hopitals again, and now we have the limit as x approaches infinity of the derivative of 8x is just 8, and the derivative of 6x is just 6. So that is the same as just 8 over 6, which is also the same as 4 over 3. So now I can evaluate my limit. My limit as x approaches infinity of 4x squared plus 1 over 1 plus 3x squared is equal to 4 over 3. Now, I believe that you have probably addressed this style of problem before. Now, I'm not exactly sure how you evaluated this. Many times what we do is we take this thing and we divide by the highest power of x, x raised to the second power, and then we evaluate the limit. And some people just memorized a trick, which is just to take the exponent of the highest, you take the coefficient of the highest exponent of x on the top and bottom, which would be 4 over 3, which is what we get right here. But this is our calculus-based method for doing that, and the preference of all calculus teachers in the world would be, let's do it with L'Hopital's rule now. Okay, next one. So again, first thing, I am checking for an indeterminate form. Hope I'm spelling that right, sorry. Oh, my screen is blowing up here. Indeterminate form. Sorry about that. So I check for my indeterminate form, and that is going to be e to the 3 times 0 minus 1 over 0. I got a 0 on the bottom. That's a good start. So that is e to the 0 minus 1 over 0. And e raised to the to the 0 power is 1. So I have 1 minus 1 over 0, which is 0 over 0, which is our indeterminate form, our first one. So that means I get to use L'Hopital. And again, you don't need to write this down every time, but I do need to see that check for the indeterminate form. So now we're taking the limit as x approaches 0. And the derivative of e raised to the 3x is e raised to the 3x times the derivative of the inside times 3 minus 0. And that is all over the derivative of x, which is just 1. So now let's see if we can evaluate that. That's going to be e raised to the 3 times 0 times 3 all over 1, which I don't need to really write. And so that is going to be e to the 0 times 3. And we again know e to the 0 is just 1. So that's just going to be 3. So now I can evaluate this limit. My limit as x approaches 0 of e to the 3x minus 1 all over x is equal to 3. Okay, we have our last one here. We are going to evaluate this limit. So again, first thing, we check for an indeterminate form. So we check for our indeterminate form, and we do that simply by plugging in 1 for x. And when I do that, I get 1 plus 1 over 1 squared plus 1. And that comes out to be 2 over 2. Is that an indeterminate form? We do not have an indeterminate form, which simply means I cannot use L'Hopital's rule. So I just evaluate the limit, which is exactly what I just did by checking for the indeterminate form. So I'm actually finished. I evaluate my limit as x approaches 1 of x plus 1 over x squared plus x. And the value of that limit is going to be 1, which again is what I just did. 2 over 2 is 1. So when you do that check for your indeterminate form, you're actually partially answering the question, even if L'Hopital's does not apply. So bring any questions you have to class, and I hope you have a wonderful evening.